Hello class, and thank you for watching this video on unbounded intervals. What you're going to learn in this video is how to write an unbounded interval using inequalities, a number line, as, and in interval notation. Let's start with inequalities first, okay? And let's discuss when we use brackets and closed circles are used, when we're going to use those. Well, first of all, a bracket or closed circle, as stated right here, indicates that the endpoint is included in the interval, while parentheses or an open circle indicates that the endpoint is not included on the interval. So for example, here we have a situation where we want to determine again and identify when is x going to be greater than or equal to a, and the difference between x being simply greater than a. Well, if x is greater than or equal to a, that means that we have a closed interval, a closed unbounded interval, in this situation where a is the endpoint and we're going towards positive infinity, as you see right here indicated in this diagram. The diagram right here, the number line down here, which is represented as the interval there. So, and the difference between saying that a value of x is strictly greater than, only greater than an endpoint a, represents that we have an open interval. So a is going to be represented with an open interval going towards positive infinity. So we have an open circle and still pointing to the right towards positive infinity, but the circle, the endpoint, is now going to be open. So we use this notation to know when we're going to use a closed and open unbounded interval. So for example, again, in this situation, while this is in the technical term for this is greater than or equal to, so let me write it here, greater than or equal, I used to just a closed inequality, okay? My closed greater than. And while the technical term for this inequality is simply greater than, is greater than, I lovingly call it my open greater. Okay? Well, greater than. So when we're using those symbols again, that means our interval is going to have a closed bracket. So right here we have a closed bracket and an open bracket or open parentheses. So bracket, parentheses in the respective location. And of course the graph correlates to this idea. Notice that the graph is pointing towards the right, towards positive infinity, and look how it matches again to the interval notation. So from a to infinity, a closed to infinity, So you see, the number line correlates directly again to the interval. So now let's look at the other direction, the less than. And with the less than, well, we have the same situation. We have the situation where we have a closed less than and an open less than. So let's first write the technical term, okay? The correct term to call this symbol here, this is less than or equal to. I will simply periodically just simply call it the closed less than. Closed means that it's going to equal to. And while it doesn't have the equal sign, this is strictly is less than. No equal to, okay? Which I will refer to it at times as the open less than. Now, since the endpoint b, again, in this situation, the endpoint is b, notice how we represent this interval, how we represent this inequality as an interval. Since we're saying that the values of x are going to be less than the endpoint b, that means that we're pointing again towards the left on a number line, which means that the values are going towards negative infinity. They're unbounded towards negative infinity in both situations. B, being the endpoint, will be closed again if we're using the equal sign symbol. Again, the closed inequality. And it'll be open if we're using the open inequality symbol, strictly the less than symbol. Now the interval is written backwards now. Notice that the endpoint B is on the right side of the grouping symbol, the open and close brackets, and then the open and open parentheses. And the infinity goes first this time. The reason for that is that on your interval notation, the smaller number, whether it's this one on the left or this one on the right, the smaller number always goes first. And negative infinity is always going to be smaller than whatever this endpoint is for B, whether it's open or closed. So let's look at some examples of this, okay? And we're going to use a number line to get the inequality and the interval, and vice versa. Use the inequality, as you see right here, to get the number line and the interval, and then use the interval to get the inequality and the number line. So let's start with the first example. Example number 1, okay? Here we have the number line where we have an open circle at 3. So 3 is the endpoint. That's your endpoint. And the arrow is pointing toward the left, towards negative infinity. So as an inequality, that means that x is less than 3, because all of your values are to the left of 3. See, we're going to the left, so that's going to be less than that symbol right there. Now, since the 3, the endpoint, is using an open circle above it, that means we're going to use the open less than. No equal sign then in this situation. So this inequality represents this number line right there. Now, to represent this inequality as an interval, well, we follow the same idea. Using, again, the number line, we see that negative infinity is to the left of positive 3. So we're going to start by writing negative infinity, comma, positive 3 in that order. So it matches again perfectly to this diagram there. Now, let's put the correct parentheses. So on the infinity, that is always going to be open. So we're going to use the open parentheses on that one. And on the 3, because again, it's open, we're going to also use the open parentheses on that as well. So this is going to be the interval. Let's see. Let's do the second example. Second example, notice that 11 is your endpoint. So we're going to have x and 11 for the inequality. And to determine if we're going to use this symbol, the less than symbol, okay, or the greater than symbol, well, we have to look at the direction that we're pointing at. So 11, we are pointing towards the right, towards positive infinity. Well, towards the right, that means that the values of x are going to be greater than. So we are using this symbol there. So x is greater than 11. And since we have an open circle, we're going to use the open greater than, and not the closed greater than. The closed greater than will have the equal sign. So in other words, we're simply using strictly greater than. Okay. Now, as an interval, well, let's look at our diagram. The diagram gives a great example of how to write the numbers for the interval. So since 11 is to the left of infinity, that's the order we write them in. So 11, comma, positive infinity. Now with the infinity, automatically that's always going to be a parentheses. But now for the 11, we'll have to use either a bracket or a parentheses depending on the type of circle. And again, just to review, because it's an open circle, let me go back up over here. Again, open circle, like on this diagram right here, we're going to use again the parentheses, the open greater than symbol, and that means we have to use parentheses on the endpoint. So here, our value of a is 11, so we're going to use again our open parentheses. So this will be the interval notation that represents this number line. Okay, now let's look at the second set, numbers 3 and number 4. Well, starting with number 3, here we have this inequality. So let's draw the number line first. So for a number line, we have the number 0 in the middle, and the arrow is pointing towards the right. again, this is greater than. And it's going to be an open greater than because it doesn't have the equal sign. So in other words, it's greater than, or I'm sorry, strictly greater than. Not or. So it's an open greater than. So we're going to put an open circle above the 0. And since all of the values of x are going to be greater than, that's going to go towards positive infinity. So this would be the number line that represents this inequality. Now that we have the number line, we can write our interval. So according to the number line, just to give us an idea, since 0 is to the left of the infinity, that's the order we write them in. So 0 and then infinity second. Use parentheses on the infinity always. And then on the 0. Well, again, since this is open, we're going to use parentheses on the 0. Now for number 4. For number 4, we have that x is less than or equal to. So this is less than or equal to, which means that this is going to be a closed interval, a closed unbounded interval. So we're using the closed less than inequality. So on our number line, we'll put 17 in the middle. We're going to close the circle on the 17. And since the numbers are going to be less than, that means we're going towards negative infinity to the left. Towards negative infinity. So my interval notation would be negative infinity, positive 17, close the negative infinity. Again, whether it's positive infinity or negative infinity, that is always going to be a parenthesis. So right here, this parenthesis, parenthesis, and this one right here, parenthesis. And now on the 17. On the 17, again, since we're using the closed circle, again, the equal sign, we have to use the appropriate brackets. So we have to use a bracket this time instead of parentheses. And now finally, using the interval to create the number line and the inequality. Well, let's start again with the number line. The number line is easiest to do, whether we're given the inequality or we're given the interval. So with the interval, we would start off with 4. Notice again how the interval is written. 4 and then infinity to the right. So 4 is the endpoint, and we're going towards positive infinity. So we're going to put a circle around 4 and pointing towards the right. Now, do we have to shade it in? Well, because we're using a bracket, that means that this circle that we're drawing above the 4 is going to be closed. So we are going to fill it in and close that circle. So that would be the number line. Now let's look at this. Using the number line, we'll look at the endpoint. The endpoint again is 4. And we're looking at the values to the right of 4, again pointing to 4, so that's going to be greater than. And again, to continue correlating with the closed one, to make sure that we know that this inequality has to be closed, we put an equal sign underneath it. So x is greater than or equal to 4. And now the last example. Well, the last example, look at what the endpoint is. The endpoint is going to be the 1, all right? So we'll put the 1 in the middle. Notice that the infinity is on the left side. So negative infinity. And look how that matches again perfectly to the interval. So my number line is from negative infinity to 1. So we're going to put a circle around 1 and point it towards the left. Now, is this 1 going to have an open, or are we going to have to fill it in right now? Well, let's look at the endpoint. At the endpoint 1, notice that the parentheses that we're using is an open parenthesis, a regular parenthesis. So because of that, that means that this is open. So we're going to keep the circle above the 1 as an open circle. And there is our number line. Now to represent this as an inequality, we have x and the endpoint of 1. Since we're pointing to the left, we're going to use the less than symbol. Our arrow points to the left, so less than symbol. And again, because the circle above the 1 is open, we're going to use the less than symbol without the equal sign, the open one. So this would be the open one. If I put an equal sign underneath it, this would have to be closed and this would have to be a bracket. That's the only difference between those. Well, there you have it, guys. This concludes the examples on how to write and graph an unbounded interval using inequality and interval notation. If you have any questions, please send me a message on Remind and check the due date for your assignments. Thank you for watching, and I hope you have a wonderful day. Goodbye.